state in the database once it's reached its limit, and then have it email itself to say, hey, do some work, here's your last state. Okay, essentially what you're creating is a loop inside of Salesforce.com that'll keep going and keep doing your work for you. Okay, once we've built all these things, we've essentially got a loop. We can tell it to do any work for us, and it's going to keep doing it. So one of the things we questioned was what we could do for proof of concept, and what we settled on was something called Sifto. Okay, we took the popular Nikto CGI scanner and we ported it into Salesforce.com, so Nikto lives in their cloud. Okay, the thing to remember here is that this is proof of concept. We could have done anything. Essentially, we're using free computing time that now belongs to Salesforce.com. Okay, so if you take a look at this example, and I'm going to go through it really quickly, we've already built up this in Salesforce.com's cloud, and we're using a simple wrapper here so that when we give it a target, it emails that target to our Salesforce application. Okay, and then we're tailing the Apache log file on a victim so that you can see these requests come through. Okay, what you'll see is we kicked off our scan. Salesforce.com now starts sending these CGI requests to our victim. And the moment Salesforce.com picks up a hit in the normal way that Nikto does, it then sends us an email to say, hey, I found this location on that web server. Okay, essentially you're getting the same results that you would from a Nikto test, except this now lives completely on Salesforce.com and is completely free for us. Okay, as attackers who live in South Africa where bandwidth is really expensive, this becomes attractive because it's almost as fast as the lines that we use at home. Okay, but essentially what this means is we can take any application, port it into Salesforce's cloud, and use their computing time to run our applications for us. Okay, so all we're doing there is stealing from Salesforce. Okay, so we're going to steal from a few more vendors really quickly. Quickly, the pros and cons of this sort of attack is it's really simple for us. One of the problems is there are still limits on how many emails you can send. Okay, Salesforce do have it, but it's unpublished. And so what we were looking for was how we could get more accounts from Salesforce.com. Okay, we wanted to sign up for more accounts, and it turns out that on their sign up page, Salesforce.com throw you back a captcha. Okay, so obviously this slows us down. We wanted to automate our way through this, but they've got a captcha. We do a really quick check, and if you look at the stream that comes back from Salesforce during the sign up, what we found, or what Marco found, is down here. They've got a little debug code called S-code, and what they're actually giving you there is the value of their captcha. Okay, so basically with wget, you can read the captcha and automate it. To their credit, we reported it to Salesforce and they had it fixed literally within minutes. Okay, but what it means to us as attackers is we can now scale horizontally. Okay, we can now create 200 accounts and spread our workload with all of those accounts because essentially we're building state fakely. Okay, so this gives us lots of possibilities, lots of interestingness. When you look at something like Salesforce, one of the things that should scare you is that Salesforce don't sell to security guys. Okay, they sell to sales or sell to marketing. And essentially, these security decisions start getting made by C-level execs in your organization. Okay, which should scare you a little bit. We're going to go next to Amazon Web Services. And like I said at the start, something I want to point out is Amazon Web Services is probably some of the coolest technology that I've played with in a really long time. Okay, if you haven't, you should sign up and play with it. It's lots of fun. The pieces that we're going to play with, we're going to look at EC2, S3, SQS, and DevPay. We're not going to look at the rest of them. Because I'm short of time, I'll go through this quickly. EC2, the Elastic Compute Cloud, basically allows you to hit a web page, say I want 10 boxes that look like this. They boot those boxes for you, and suddenly you've got boxes that you can use on the internet. Okay, it's really cool. S3 is their storage service. Basically, they've got what they say is they're using the storage in buckets. Okay, and what they do is they've got a flat namespace that I'll come back to in a little bit. But if you look at any of the tools, essentially it gives you disk storage that lives in the cloud. You don't have to worry too much about what's happening in the background. It's becoming really popular. Already by January 2008, they were storing 14 billion objects in S3. Yet all of this is stored in a flat namespace. Okay, I'll tell you why I keep going to this, because you're going to see how it's going to hurt them shortly. But basically, if you go onto S3 and you create McCulver images, everything after that that sits under that belongs to you. And there's no limitation on, or there's very few limitations on what you choose as your S3 name. Okay, SQS, it's a normal, like, abstract data type. You've got a queue object that sits in the cloud, allows you to pop stuff and push stuff off it. Works just like a normal queue does, except Amazon hosts it for you. Okay, so when we were looking at what to do, I wanted to find out what coolness we could get from Amazon. The simple thing to do is to do what Marco did. Let's see if we can steal computing resources from Amazon. Okay, and the easy answer is yes, we can. Okay, so if you look at how Amazon Web Services works, you go to a web page and you say, which of these boxes shall I boot? You click on a box and you boot it. Okay, what's interesting is if you look at the number down here, okay, there's nearly 2,800 images. Okay, Amazon only built 47 of them. The rest have been user contributed. Okay, so typically when someone goes to Amazon and they boot one of those machines, chances are they're probably booting a machine that was built by Joe Public. Okay, they've got no way of knowing what's on those machines. So we wanted some way to scan them, but of course, Amazon won't let you scan in their cloud. Okay, so it's almost like we've taken a step back. We weren't quite getting things right with Qualys and scanners like that, trying to scan our network, and now we're building networks where we're not allowed to scan them to begin with. Okay, so it's not great for us. So what we did really quickly was built a really ghetto scanner, where what our scanner does is it goes onto the internet, goes to Amazon, and gets a list of all possible machine images. Okay, Amazon then limits you to 20 machines, so we fire up 10 instances. Each of these instances then fetches from the SQS queue and says, give me another image. We then fire up that image and scan it. Okay, and for scanning here, we did really simple stuff. So we NESA scanned it, and we did some file system checks that we were interested in. Okay, we then take those results, populate it into an S3 bucket, and read those results off. Okay, what's interesting is just from that initial scan, you find at least 1,200 high, 700 just about critical vulnerabilities on those boxes that are now living inside of Amazon's cloud. What's more interesting than that for us is this screen, which you probably can't read at all. Okay, so what we're doing here is we're going into every image that we fire up, and we're looking on the file system for interesting files. Okay, where we define interesting as people's bash history, people's private keys, people's Amazon keys, and what you get is all these pages and pages of private information that's still left on those Amazon images. Okay, all of these are the Amazon keys that Amazon used to identify you. So clearly what's happened is people have gone, created images, but not taken their private credentials off those images before sharing them with everyone. Okay, so you could just go onto Amazon, fire up these images, look for private information, become someone else, and then use their computing time. Okay, while we were stealing, we figured there must be a better way than just robbing Amazon's customers, like the last attack did. And instead we said, let's see if we can rob Amazon directly. Okay, which takes us to really simple license stealing. Okay, so Amazon also give you Win2K3 images. Okay, if we fire one up and then use the very elite Magic Jelly Bean tool, okay, basically what Magic Jelly Bean does is tells you what your running registration information is. So we go there and we extract the license key from one of Amazon's Win2K3 images. Okay, we then take this license key back home, put it on our server, and it happily works. That server also happily still Windows updates, so it passes Microsoft's genuine advantage. Okay, so essentially anytime we need a Win2K3